So, honestly, they're sweaty. I mean, it's a dry sometimes. But like literally, I think they're like this. Because the roof is hitting your head. It was like, you know, this like swing room? Like those tubes. Something like that. Yeah, there's windows on the top of the roof.
Alright, on our, I told you yesterday, I gave you a little bit of preview yesterday. When we're graphing rational functions, remember rational means can be written as a fraction. And we talked about the only number that can never be on the denominator of a fraction is zero. So we're going to run into some limits on these graphs. So that means we're going to have asymptotes on these graphs. And so that's going to be our biggest job, is determining what the asymptotes are, because then it's real simple just to draw the branches, and that's what they're called, the parts that we're going to graph, branches, just to draw the branches off of the asymptotes. Now these things, I'll just show you, these graphs are actually, the rational function graphs are actually called hyperbolas. So this is what the, don't get mixed up with English class. This is what the parent function of a hyperbola would look like. And these pieces are called the branches. So that has two branches on it. Okay, so that's what we're going to look at doing today. I'm going to start us off with a real simple one, and then we'll get more complex ones as we go. Okie dokie, artichoke. So we got a hyperbola. It's kind of spelled like hyperbola. That has branches. Alright, so I'll graph for real what would be called the parent function that I just kind of sketched in a hurry over there by Hunter and River. F of x equals 1 over x, so this would be the parent function of a hyperbola. Let me write that word for you so you'll be able to spell it. I'll look at my notes, my book, and spell it right, so I'll get it one time. Hyperbola. Very good. Alright, so what we know on this is that x, on this parent function, x cannot be 0, right? Because that's what, if you did 1 divided by 0, you get an error. You can't do that. So, in this case, when you're just your parent function and all you have on the bottom is an x, in this simple case, your asymptotes are the axes. Okay, so I'm going to highlight them up there for us. So, usually I'll draw my asymptotes with a dotted line, but since it's the axes, you wouldn't be able to see it very good. I guess I could have drawn a dotted highlighter line. That would have been but I didn't start that. Alright, so now the process that we're going to go and the process, confused about what? All we done was...
I'm confused.
The asymptotes. Y equals 0 means you don't go up or down any, so you're on the x-axis. X equals 0 means you don't go right or left any, so you're on the y-axis. Okay. That's not new stuff.
No, I just feel like I need to write it.
Okay, write it down.
I was just kind of confused because it says x is not equal to 0, and then below it says x equals 0.
Well, so I didn't organize that well, in other words. X cannot be 0 because that would make that undefined.
Right.
But I've got, so that asymptote by definition means I don't touch it.
Oh.
Alright, so your process for graphing these dudes, whether it's a simple one like this or a more complex one that we'll end the class period with, are going to be, first off, get your asymptotes drawn. After you get your asymptotes drawn, wherever your vertical asymptote is, just like over there by Hunter on the dry erase board, you're going to graph some points to the right of it, and you're going to graph some points to the left of it to form your branches. So if I'm thinking about my old school input-output table, some numbers to the right of this, 1, 2, 3, right? Okay, so I'll plug those in. Some numbers to the left of this, -1, -2, -3. Just keeping them simple and small. So those are the numbers that I'm going to plug in to graph. Now we'll see before we get done today, this asymptote's not going to be on 0, so we'll have different numbers to choose. But real simple, you're just plugging those in for the x. So when x is 1, 1 divided by 1 means my y is 1. What about when x is 2? What's 1 divided by 2? 1/2. So this one will be 1/3. So you can see the farther we come over here,
the
closer we get to 0. But remember, we're never going to touch it, right?
Right.
Okay. So that's what's happening on the little scenario that I drew for you. All right. So -1, 1 divided by -1. -1, 1 divided by -2, -1/2, 1 divided by -3, -1/3. All right, so I'm going to go to my, it doesn't matter which side you do first. It's kind of weird that I started on the right because, we read a book left to right. But I'm going to go plot my one on the right and draw that branch. Over 1, up 1. Over 2, up 1/2. And then over 3, up 1/3. Now don't draw a line. Okay, I gave you an idea over there on the dry erase board. Your hyperbola branches are curves. So it's going to get real close to this yellow line, but never touch it. It's going to get my points maybe. And then get real close to the x-axis, but never touch it. Okay, now I need to draw my other branch. And what you're going to see happen here, and like we've already got it on the dry erase board over there, normally the branches are complete opposites. Like if I got a branch in quadrant 1, my other branch is going to be in quadrant 3. That's pretty normal for you. All right, what do I got? Left 1, down 1. Left 2, down 1/2. Left 3, down just 1/3. What? Right here. I went left 1, down 1. That's that point. Left 2, down 1/2. That's that point. Left 3, down 1/3. So they get closer and closer to the asymptote, but they don't touch it. There's your other branch. So there's your parent function of a hyperbola. Whoop, whoop.
Woo.
You do have to snap at him.
Communication is not our relationship.
How do you spell asymptote?
ASYMPTOTE.
Oh, this is on
Oh, that's not.
Oh my goodness. Oh my goodness. Alright, so I'm fixing to get another piece of scrap paper. Right now on your notes, I want you to see if you can graph that. Y equals 4 over x. Go. In your notes, Chloe, I want you to see if you can graph that. Now, we haven't learned anything new about asymptotes yet. We got an x on the bottom, and that's all. So anytime it's just that x on the bottom, your asymptotes are going to be on the axes. So you can pick the exact same points I did before. 3 to the right, 1, 2, 3. 3 to the left, -1, -2, -3.
Oh, got it.
How many weeks do we have left in this 9 weeks?
I don't know if that has anything to do with this graph. But, I mean,
Do you have to?
no, in my opinion, I can do something that's this simple, easier without the calculator. But you can, I mean, you can always put them in a calculator. Sometimes on these, when they get more complex, their pictures are harder to get an idea of, but this one's not bad.
Question.
I'm listening.
Is the graph always going to look basically the same?
Just be moved, yeah. It'll have those two curved branches somewhere. Yes.
Come here.
Oh, I missed that one. Oh, look at me. Went across the asymptote, missed that point. I'm screwing all that up. I'm just gonna erase it to that point and try it.
You can put a line through the chart.
Where's making fun of me? I think you are.
No
Makes fun of
making fun.
everybody.
No making fun. Just
I think Jason is feeling pretty proud today. We're gonna have to take him down a notch.
I got it.
I knew Chloe would be willing to help on that.
I already did. I had to do a presentation. I did. Stuttered and
I would have paid to see that.
Spanish.
I did do a skit in there yesterday. It was,
I'm just gonna make that point there, not now. Okay, so how, you've still got the first one, the parent function, the 1 over x, you've still got that one on your notes. So I wonder how this one would compare to that one. It didn't scoot anywhere, right? Because we still are approaching the same asymptotes. So I'm thinking with all those transformations that we've learned, wonder if this could be some sort of shrink or stretch. Yeah, maybe earlier we had a point at over 1 up 1, and now I've got a point at over 1 up 4. So I could say I vertically stretched that by 4 units. How about those apples? Look at y'all connecting stuff. All right, let's look at a more complex.
is that point? I was just waiting for it. Coach me back to yesterday too. I was like, he's just like, come on, back up.
I don't want to do it.
You're too bad, so sad. All right, write that down. That says y equals -4 over x plus 2 minus 1. That minus 1 is stuck on the end of the whole fraction. Now, after you get the function written down, look up there on the dry erase board at what I wrote.
Y equals
That was familiar.
The A, remember on that last problem, it was 4, and we said it stretched by 4, and then when we changed our A on all our old functions, multiplied our by some number A, didn't that mean shrinking and stretching? What about over here with an H and a K? Did we ever have anything that was in with the X or that was stuck on the end? Okay, so that's where when we've got something that looks like this with an H and a K, that's where your asymptotes are going to come from. So we're a little bit more complex. So we got to do a smidge more work to find our asymptote, but not a lot. All you're going to do is take that denominator, because you know you can't have a 0 on bottom, and figure out what would make that a 0. If x was -2, it would be a 0, right? So that means -2 is going to be your asymptote. So I'm going to go x, -1, -2, and I'm just going to draw a dashed line through that. Okay, now remember, when we stick something on the end, that moves it up or down, right? And that goes the correct way of the sign. So what did ours have stuck on the end? I've forgotten. A -1. So that means our horizontal asymptote is going to be down 1. Okay, so back to the origin. Go down 1. I'm listening, sweetie. Go down 1 and draw your dotted line
Wait,
there.
so why did we go down one?
Because our K is -1.
Oh, okay, sorry.
That's okay. Alright, so we've created those same 4 sections, but on the first 2 graphs we did, they were sectioned at the axes. So we've just taken those 4 sections and moved them left and down. So when we start choosing our points now, our X's, we're going to choose some on the right side of this line and some on the left side of this line, and everything's going to work the same. Okay, so let me scroll it up so I can see my equation to work with. So on the right side of this line's at -2. So to the right of that, I could do a -1, a 0, and a 1. It's just my preference. You can pick anything you want, but it's just my preference. Always pick the smallest whole numbers closest to it. Does that make sense? Okay, so to the left of that line, this is at -1. So to the left, I could do -2, -3, and -4. Oh, my bad, it's at -2. It's at -2, so I can't do -2. My bad, I was looking at the Y. So I'd do -3, -4, -5, won't I?
Yes.
If I stick to my personal preference. Okay, I'm going to do this on the dry erase board. Now, what Riley was talking about earlier, she said she'd forgotten that her calculator could do these. You can plug that into your Y equals on your calculator. I don't have a problem with that. Go to your table and get some points to plot. I don't have a problem with that. But you need to make sure you're real careful on this fraction stuff when you enter this. Get it all in how it's supposed to go. So anyway, the reason I'm saying that is because if you've got your table on your calculator, you can be checking my workforce now. -4 over -1 plus 2 minus 1. Okay, so I'm using my order of operations here. So I got -4 divided by 1, right? So -4 minus 1. Make my first one there be a -5. Is that right? Everybody done it in their calculators? -1x is -5y.
Yeah.
Okay, so now I'm going to change to a 0. -4 over 0 plus 2 minus 1, so it's -4 divided by 2. So I get a -3. Okay, filling in my table. Now I'm going to change to a 1. So that's -4 divided by 3, so it's -1 1/3. -1 1/3 minus 1 is -2 1/3. Did it say -7/3, Riley?
Yep.
All right. I normally would write the -7/3, but if I've got to graph it, it's easier for me to estimate it if I put it as a mixed number. So that's the reason I did that. It's like watching TV. Can't tell what it is. Must not be very good. All right, plug the -3 in. Guess I still need to write them down. -4 over -3 plus 2 minus 1, so that's -4 over -1, which is 4. So I get 3. I'm checking Riley because she's checking. Okay, -4. So -4 plus 2 is -2. -4 divided by -2 is 2. So 1. And I got one more. -5. So that's -3, so that's 1 1/3 minus 1 is 1/3. My mental math still works, Hunter. If I'm ever stranded on a desert island without a calculator, I can split coconuts into thirds. It's a good skill to have. Alright, so I'm ready to graph finally. Left 1 down 5. 4, 5. And then I had over 0 down 3. 1, 2, 3. And then my other one on the right side was 1, -2, and a third. Alright, let me drop that asymptote a little lower. Now, so this one's in the bottom right quadrant. We haven't drawn one down there yet. So when you get ready to connect these, just remember what your hyperbola branch is supposed to look like. And it's got to stay in that little quadrant we've made with our dotted lines, our asymptotes, and we can't touch our asymptotes. Okay, so I'll start down here. Ooh, dang it, one of these days I'm going to hit all my points, but it ain't today. Make that one bigger. Okay, so odds are, if you're a bettor, and I'm not because you got to have money to bet, but odds are my other branch is going to be in here. Okay, that's what to expect usually. Now there are weird cases we're going to see where we have more than one vertical or more than one horizontal asymptote. Not today, but they're going to end up being pieces all over. It's crazy. Crazy out there, Wills. All right, so left 3, up 3. 1, 2, 3. Oh, I got to scoot it up. Let's count again. 1, 2, 3. 1, 2, 3. Left 4, up 1. Left 5, up just a third. Hey, I was right on my guess. Now, don't get scared of this axis. That's not my asymptote, so I can come below it. I just can't go below that dotted line.
Yeah.
Something like that. Cool stuff. Now, I'm looking on Riley's calculator. It looks like a pretty good rendition there. Did anybody else check them on the calculator? Good stuff. Able to get points and plot. All right. We're going to look at step it up another level next, so get ready, Freddie. I ever see those old movies where the college professor has his chalkboards and you can fill one up and then just roll it. And I wish we had that with dry erase boards. I'd be like shooting dry erase boards all across the room.
That'd be kind of
Cool stuff. Cool stuff.
Do math teachers actually write that fast in college?
I don't remember if any of mine did or not. I don't know.
Riley would ask for help. You just shoot the board across the room.
Here it comes, Riley. That'd be cool.
That'd be terrifying.
Remember how long I had to beg to get dry erase boards on every wall in here? It took me about 1.5 years. He was like, nobody wants that. And I said, I do. The kids are going to use them. And look how much we use them now. It's good stuff. So then, get rid of that bookshelf, we'd have room for another one. But then what would I do? Make Alyssa hold all the books?
I would do it pretty
Oh, you just have to get another short bookcase like that one.
Oh yeah, you can do that.
Yeah. That's,
But you can't really write on the middle one.
Where did you put the hats though?
I'll wear them on. You can hold the books.
No, we learned this morning those hooks don't hang on the wall.
Oh yeah, I walked by there and all of them broke. Miss Stewart's, yours did.
Miss Stewart's
What was
did.
it? Oh, it didn't?
They gave us those in God We Trust things, and because I don't know, some legislation must have passed, and we gotta not. I mean, I'm glad about it, but we had to hang them in every room, and they gave us a command hook. So I thought, well, it needs to go on the flag. So I climbed up on the wall and hung it by the flag, turned around, and it crashed to the floor, and that broken glass was all over the floor. So then Mr. Withers sent an email and said, don't hang them on concrete. That's what we got. So they were like they didn't order extras, and so they're like, we don't know what we're going to do. So I said, I don't want another one. It's just going to get broken. I'll just put it in the frame without a glass and lean in to get some. So there you go.
I appreciate it. I think I know.
Miss Miss Reed said hers broke, but Miss Stewart hadn't hung hers up yet. She'll probably need assistance.
That must have been your glass, because someone
Yeah.
came out of there with a bucket of glass.
Yeah, Miss Andrea was helping me clean it up. Okay, here is the form of the last type. Alright, so what we're going to do on this one, and it'll look better when we've got numbers in where the A, the B, the C, and the D are, because those will be numbers. You'll just have your X that stays. But what we're going to do to find our vertical asymptote will be the same. We'll set our denominator equal to 0 and solve. Okay? To get your horizontal asymptote, which is where your Y equals, your Y will equal to the coefficient of your X over the coefficient of your X in the denominator. Alright, so I'll start us off here with g of x, just because I haven't used function notation yet. G of x equals 2x plus 1 over x minus 3. Now, I think y'all are all pretty much here to finish the year out.
No, I'm quitting. Bye.
Well, I mean, transferring to a different school, because this, how I'm fixing to teach this to you can be taught different ways. So if some people will teach you to transform this into that form that we did on the previous one, where it's got the a over x minus h plus k. I don't do that. I think that's more hassle. I'm just going to graph it like what we've been doing. I'm going to find my two asymptotes and then pick some on the right, some on the left, and do it like we've been doing. I think that's simpler. So to get my first asymptote, just like what we've always done, we'll set our denominator equal to 0 and solve. So we've got a vertical asymptote at x equals 3. Okay? Now, sometimes that x might have a number other than 1 in front of it, so you'll have some dividing steps to do, but this one, we were fortunate, it was just a 1x. All right, I'm going to go right 3, 1, 2, 3, put my dotted line there. Okay? Now, to get my horizontal asymptote, y equals, what's our a on the numerator?
2.
2 over, what's our a on the denominator?
3.
No.
X.
X.
How many x's?
Oh, just one.
1 X.
1. So my horizontal asymptote is at y equals 2. So we're going to go up to 2, and will be a horizontal line through that. Okay? So we've scooted that quadrant system of our dotted lines to the right and up now, haven't we? Okay, so I got a lot going on up there, so I'll pick some points over here. This is my line. It's the vertical line that you pick to the right and left of. So 1, 2, 3. So I'm going to use 4, 5, 6. Okay, and then I need to pick some on this side of it. So 2, 1, 0. Everybody okay on those? And you can pick anything you want. If you plugged it in your calculator and you see some prettier whole numbers than what these are going to get you, you don't have to use these. Okay, but this is what I picked, so I got to stick it out and use them now. Now, looky here. You've got 2 places to plug them into, right? Okay, so 2 times 4 plus 1 over 4 minus 3. So that's 8 plus 1 is 9 over 1. Alright. 2 times 5 plus 1 over 5 minus 3. 11 over 2. So that's going to be 5.5. 2 times 6 plus 1 over 6 minus 3. So 13 over 3. 4 1/3. Okay. Now on my ones on the right. 2 times 2 plus 1 over 2 minus 3. 5 over negative 1. So it's negative 5. 3 over -2, -1.5.
Yes.
-1/3. Anybody calculators check us on those? They good? Alright, so I don't think I saved room for that 4 or 9. I'll just estimate way up there at the top. This will be 4, and it'll be way up there at the top somewhere. And then 5. 1, 2, 3, 4, 5, way up there at the top. Let me draw my asymptote up there through that. And then 6, 4, 1, 2, 3, 4, and 1/3. Alright, so I'm pretty bad on these points because I should have counted on every line. I didn't think ahead and plan that very well. I will for my other classes. But I know I'm in here, this quadrant, and I know where my asymptotes are. So I just want to draw, and it doesn't have to, like it's not, I mean, this point at 5 is way up there. So it's not going to be touching the asymptote yet. So it might not get close to that asymptote until way over here, right? I've got a bad section. I didn't count very well. So it's okay for that thing to not be on my asymptote yet. If I continued this out, that curve would eventually get in the range of mine. Does that make sense what I'm talking about? Y'all follow that? Okay, so this one I expect to be down here. Do my points look like they're going to be kind of that? Yeah. How about 2 negative? Oh, shoot. Oh, well, at least -5's the only one. It'll be at the very bottom. 2 right here. 1, 2, 3, 4, 5. 1, -1.5. 0, -1/3. Alright, so I did the other one in blue and I did this one in black. That was not very good planning. See, I had more room on this side, so even though my last point was at 0, because I had more space over here, I went ahead and extended it up to that asymptote.
I don't know what I did.
My graph is heavy on the right side, so I didn't have a lot of space over there.
I think I colored that one wrong.
Yeah, you because you don't have any negative x's.
Yeah.
Alright, so it's possible that you can have a rational function to graph on the ACT. That's in the bank of things. That's possible. If I like doing this because this was just basic operations. There was no hard math. I could do most of that mentally. It was just pretty basic. But if I were in your shoes, bless you, if I were in your shoes and I was doing this on the ACT, either as a junior next week or some glorious Saturday morning, to save time, I would probably do that in the calculator. But it's not hard. Y'all just saw me do it without a calculator over there. It's not hard, but 60 questions in 60 minutes. Did I really need to waste all that time doing that kind of deal? So practice with the calculator so that you know how to use them and you can get that done. All right. Yesterday we did inverse variations. Y equals some number divided by x. Today we learned to graph rational functions. Tomorrow we're going to hit the brakes and do an assignment over these 2 lessons. Okie dokie? Wednesday.
Wednesday.
And